Welcome to EDU World Space.
So here we'll be using the equation of continuity and then Bernoulli's equation in order to find the gauge pressure at the top of the building. So in order to do this, we should first say the cross-sectional area at the street level times the velocity at the street level will be equal to the cross-sectional area at the top of the building times the velocity at the top of the building. We can just say that the velocity at the top of the building will be equal to the velocity at the street level times the cross-sectional area at the street level divided by the cross-sectional area at the top of the building. We can actually solve this. So the velocity at the top will be equal to 0.68 meters per second multiplied by pi times 1/2 of 0.05 meters quantity squared. And then this will be divided by, again, pi times 1/2 times 0.028 meters quantity squared. And we find that the velocity at the top of the building will be 2.168 meters per second. So at this point, that's the end of the equation of continuity. So let's just star this value and let's use Bernoulli's equation now. So with using Bernoulli's equation, we can apply it at the street level and the top level. So we have the atmospheric pressure plus the gauge pressure at the street level. We'll just say ST, and then plus 1/2 times V times the density times the velocity at the street level squared plus the density times the acceleration due to gravity times the height of the street level. And then this will equal the atmospheric pressure plus the gauge pressure at the top plus, again, 1/2 density velocity at the top squared plus the density times acceleration due to gravity times the height at the top. So at this point, we can say that the gauge pressure at the top, we're going to isolate this term, and this will equal the gauge pressure at the street, given that in this equation, both the atmospheric pressures cancel out. And then this will be plus 1/2 times the density of water, and then velocity at the street level squared minus velocity at the top squared. And then this will be plus the density of water times the acceleration due to gravity, the height at the street level minus the height at the top. Now, we can actually just plug in directly. So the gauge pressure at the top will be equal to 3.8 atmospheres times 101,325 pascals per atmosphere. And then this will be plus 1/2 times the density of 1,000 times 0.68 squared minus 2.168 squared plus, again, the density 1,000 kilograms per cubic meter times the acceleration due to gravity 9.8 meters per second squared, and then this difference would be -18 meters. And we are getting that the gauge pressure at the top is going to be equal to 2.064 times 10 to the 5th pascals. Or we can say that the gauge pressure at the top is approximately equal to 2.0 atmospheres. And so this will be our final answer. You can also express it in Pascal, so this could be your final answer as well. That is the end of the solution. Thank you for watching.